Okay, hello everyone. I wanted to redo the problem we did in class to get a better understanding and to just reset this up. So if you already did this, just let's restart it. We're starting it from scratch. All right, so here we have, let's read the problem. Two chemicals A and B are combined to form a chemical C. The rate or velocity, okay, so that's our derivative of the reaction, is proportional to the product of the instantaneous amounts of A and B not converted to chemical C. Initially, there are 40 grams of A and 50 grams of B, and for each gram of B, 2 grams of A is used. It is observed that 10 grams of C is formed in 5 minutes, so that's x of 5 equals 10. How much is formed in 20 minutes? What is the limiting amount of C after a long time? How much of chemicals A and B remains after a long time? All right, so here we have, I put a couple of things down. X of T will be our amount of C at time T. So I know we have the model on there, but I want to make sure we understand because there are some other things. I gave you sort of the basis of the model, but there's some other things we need to make sure we consider and understand in terms of setting up this model. We also know that in regards to time, we also know that x of 0 will equal 0. Okay, so let's assume, let's say that 2 grams, I'll use a different color. Let's say that 2 grams of C is present, right? Well, we know that in this case, each gram of B, for each gram of B, 2 grams of A is used, right? And so therefore we know A plus B equals 2 because they come together to form C. But we also know that A equals 2B since for every 2 grams of A, for every gram of B, 2 grams of A is used, right? So you guys get that. So if there's, looking in there, if there's 1 B used, and that's two A's being used, okay? So that's how you read that. Oh, that eraser is very big. Okay. Now, if we were to solve, because we have 2 unknowns and 2 equations, so we can solve. So if we were to solve, so if I'm substituting this in, so this, I'm just looking at an example so you all will see how to set this up without necessarily, we're keeping the model in mind, but just from what it's asking us to do, okay? And so then we'll have, 3B equals 2, and so B equals 2/3, and then if we go back, then A is 2 times 2/3, okay? And I should keep it like that, but okay, that's 4/3, right? Here's the thing, we know for every, I'll do it like this, for every 1 gram of B, there are 2 grams of A being used, okay? And so what we have here, if we sort of look at this, for X grams of C, well, in this case, our X grams of C is 2, but in general, for X grams of C, we must use 1/3 X grams of B and 2/3 X grams of A. All right, and I just got that from looking here and looking there. All right, so this is for a specific example. But we're told that the rate, so x prime of t or dx dt, it's actually proportional to the product of the instantaneous amounts not converted to chemical C. Well, what does that mean? So what that means is, going back here, we see that we have 40 grams of A, right? And 50 grams of B. And we just saw that in terms of what we're going to have to use, we're going to have to use 1/3 X grams of B and 2/3 X grams of A. And if that's the case, then dx dt, they said is proportional. And I know you might see this in your book and like they forgot an infinity, but this is actually a proportional symbol. And so it's sort of like an infinity, but the right half of the infinity isn't close. And this is proportional to, well, how many? Let's go back. So we have, in terms of A, we have 40. So it's going to be 40 minus 2/3 x times, is it 50? Yes, 50 minus 1/3 x. And notice we haven't brought in the constant. We still need a constant of proportionality, but we're going to sort of clean this up a little bit before we get our constant of proportionality. And this is sort of a little trick we can do in terms of constants. We can kind of play around since we know that K is going to be our constant of proportionality. We can throw in some more constants in there, just throw it all in with K. All right. But so this is how we want to think about this. All right. So again, I'm pretty sure I messed up in terms of explaining this in class or it wasn't clear. So hopefully this is making more sense. But the key thing here is to note that the rate. So you want to check, even if you are given a model, you want to check to make sure if they specifically are telling you what this model looks like, that it matches what the model you have. And so this should be, so it's the product of the instantaneous amounts of A and B not converted to chemical C. That not is very important. And so in this case, it was going to be 40 minus 2/3 x times 50 minus 1/3 x. All right, and it's proportional, which means we do need a constant. But before we do that, we want to get rid of fractions. We don't like dealing with fractions. So we are going to, what did I do? I think I'm just going to get rid of the 3. So multiply by 3. And when that happens, let's see. And so I know you're like, what are we going to do? But it actually is going to work out for us. I'll keep that almost infinity there. And if we multiply everything by 3, it's going to look like this. 120 minus 2x times 150 minus x. Okay. I'm going to erase this. I don't like how I just explained that because I don't want to do any type of illegal algebra. So I want to make sure that you understand the algebra that I'm doing. So I'm gonna do this. So erase that thought out your mind because I think I'm teetering on doing some illegal stuff. This I know I can do legally. Let's factor out. So I'm gonna get rid of all that. Let's factor out a 2/3 in the first term and a 1/3 in the second, and let's see what happens. All right, so I think this is correct. I believe my algebra is correct. Factor out that 2/3 and then that 1/3, and I think everything is legal there. Everything is legal now. Now that looks legal. And so what we're going to do is, I'm only showing this for your notes. You don't have to break it down this far. So if I pull both of those, multiplication is commutative and associative, so we can transfer some things. And what we'll have is this 2/3 times 1/3, which is 2/9, right? Well, we're just going to tack that on in with our constant K. Okay. And so here we have finally our model. And this is, as you can see, autonomous. I haven't used that word in a minute. It's autonomous in the sense of, well, separable, but it's also autonomous because you see on the right-hand side, you only have your dependent variable, right? And so that means we know we can solve it using separable equations. And this is not my notability, so I can't just scroll like I want to. This is still Siri, but nevertheless, let's see. So we're going to have, it's going to look like, do it on the next page, dx over, what's that, 60 minus x times 150 minus x equals dt. And, oh, I'll put k dt. I'll keep the k on this side. And yes. And now we can integrate. And what do we have here? How can we integrate? Yes, partial fractions, decomposition. When we know this, we can just say plus c. I'm not going to spend time with you doing that, so make sure you do that. You might want to pause the video to do that. Okay, so now that you have it, because the magic of the internet and online notes is that you now have it. And so you should have, once you do your PFD, you should get your A and B, your constant should be 1 over 90 and negative 1 over 90. And so what you'll end up having is something that looks like this: 1 over 90 natural log of the absolute value of 150 minus x minus 190, 1 over 90 natural log of the absolute value 60 minus x equals kt plus c, which we already had. So then you should have 190 natural log of the absolute value 150 minus x over 60 minus x. All right, so we're doing, and I switched it around. Notice I switched these two around just because the minus side, and I wanted to have the difference quotient instead of, you can do the product rule too if you, no, you can't do product rule, but I wanted to be able to use the log property. Oh, I didn't want to switch that over. Let's go back to red. All right, and then after you do some finagling with constants and raising both sides to the e, what you should end up with is something like 150 minus x over 60 minus x equals c sub 1 e to the 90 kt. All right, you should know how to do this, even though we won't have a nonlinear model of this form. You might have work similar that you have to do these steps. So the process, you will definitely see again in other, contexts. All right. And so again, I'm going to leave a lot of the algebra to you, but what you should end up with is x equals 60 c sub 1 e to the 90 kt minus 150 over c sub 1 e to the 90 kt minus 1. Remember, we have x of 0 equals 0. We also have x of 5 equals 10. When you plug in 0 to solve, so x of 0 equals 0, you should get c sub 1 equaling 2.5. Okay. And if you want, now you can plug in what you know about x of 5 equals 10 and solve for your k. But it's actually, in this case, not necessary to find in order to find the limiting number. Now, you will need to know k to find how much is formed in 20 minutes. And the chemical question, I don't know if you'll need it for the chemical question, but you'll need it to know how much is formed in 20 minutes. You need to know your k. I'm actually not going to go over, you should know how to find your k once you plug this value in, but k is going to be around, I think it was 0.000125 All right, so make sure you double check to get that answer. And if you don't, anytime, and I leave a lot of the algebra to you all because of time, but if you don't get any of this, come see me in my office. Come see me in my office so we can discuss it. Okay. All right. So that should be your k. But remember, the limiting value is taking the limit as t goes to infinity. And so what I'm going to do is what I call force factoring. And if you had me before, you know what that means. You might know it as something else. But I'm going to factor out e to the 90 kt from both terms, the numerator and the denominator. And so we're going to get something like this. Force factor just means it doesn't come out easily necessarily from all the terms, so you have to force it out. And this is nice because, well, these go away, right? And so we're left with 60 C sub 1 minus 150 over e to the 90 kt over C sub 1 minus 1 over, C sub 1 is 2.5, right? So we could just plug in 2.5. Okay, and when you plug in 2.5, you're actually going to get, 150 and 2.5. So this is going to change to 150. And this will change to 2.5. All right. Yes. And so what else happens? What else do you notice? Well, again, we're looking at the limit st, the limiting number goes to infinity, right? Well, what goes on there? That's going to 0. That's going to 0. So this is 150 over 2.5, which is 60. Okay. And so that's our limiting number. Okay, so that answers that question. So you see why we didn't need to know what k was in order to do that, because it sort of gets eliminated when in that exponential. But you do need it to figure out how much is formed in 20 minutes, which in 20 minutes I'll give you that answer. So double check, 29.3 grams. The limiting number is 60, right? And so all you need to do is go back and plug in 60 for x here and x there. And remember, this corresponds to the number of grams remaining in A, and that corresponds to the number of grams remaining in B. I'm over my 15 minutes that I usually like to stop at, so I'm going to stop here. But hopefully this makes more sense than what we did in class. All right.